Welcome back. This is Mr. Hassan's Maths channel, and now I'm on question number 12 from this February-March 2022 International GCSE IGCSE 0580 paper. So paper 2 here, and here we have a question about interest. So this is like under the topic of percentages, and we have a question. First question says Sanjay invests $700 into an account paying simple interest at a rate of 2.5% per year. Calculate the value of his investment at the end of 6 years. So here we're talking here about simple interest. Okay, so we need the formula for simple interest, which is just based upon the initial investment, and the formula is the interest earned is the P, which is the principal, the amount he invested, times the rate times the time over 100. Now that tells you the extra amount that he earns. It doesn't tell you his new balance, or it doesn't tell you the value of his investment. It just tells you how much extra he's earned. I stands for the interest earned. So here we know that P is equal to $700 because he's invested. That's how much he's invested. R is 2.5. We don't write percent because the 100 takes care of the percent over 100. And T is 6 years. Time is in years, so this is fine. This is in years, so T is equal to 6. This T should always be in years. So you got 700 times 2.5 times 6 divided by 100. So they cancel out. So you're left with 6 times 7 times 2.5. Okay, that gives you 105. So $105 is his interest. So therefore the value of his investment is now going to be 105 plus his original investment, which is 700. So it's $805. Okay, so that's from the simple interest formula that only tells you the extra amount. To find the new value of his investment, you have to add that extra amount to the original investment. Now part B says Mira invests $700 into an account paying compound interest at a rate of R% per year. At the end of 17 years, the value of her investment is $1,030.35. Find the value of R. So we've got to find the rate that she's invested in. This is now compound interest. So this has a different formula to it. Okay, now the compound interest formula is basically the new value. This is the value of the new investment. This is actually the interest plus the original amount is equal to the original investment, which is called P, which is the principal, times 1 plus the rate over 100 to the power of n, which is the number of years. Okay, so now we have to find V. We know P is 700. We know the R is what we have to find. We know that time is the number of years, n, that stands for the number of years, is equal to 17. So n is 17 here. All right, and what we also know here is we actually know the value of her new investment. The value of the whole investment after the increase is $1,030.35. So now we have to put this into the equation here and find the value of R. That's what we have to do. Okay, so what we can do here is we can replace the V with 1030.35, the P with 700, and we're left with 1 plus R over 100 to the power of 17. Okay, so now we want to solve this equation. What we can do is divide both sides by 700. Okay, so I'm going to write it as this for now so that we don't have any problems with decimals. I'll just write it as this is supposed to be 10,000. Is it 1,000? No, 1,000. Yeah, 1030.35 divided by 700. Make that a bit neater. Okay, and that's equal to 1 plus R over 100 all to the power of 17. Now what I want to do is I want to find what R is. So I'm going to take the 17th root of both sides. So I have this as 1030.35 divided by 700. And this gives me 1 plus R over 100. Okay, so now what I can do is I can subtract 1, and then multiply both sides by 100. Okay, so therefore I can say, I've run out of space on this side, so let me just carry on here. So therefore r is equal to all of this, which is the square root of, the 17th root of 1030.35 over 700. I've got to subtract 1 and multiply all of this by 100. If I take away 1 and multiply by 100, I'm going to get my value of r. So let me just put that all in the calculator in one go. So I'm going to have 100 times. I'm going to have I have to use this button here. There's a button here which has this like little box here in front of the root. So that means, so I've pressed shift in that button. So now I can put whatever root I want. So I need the 17th root of, inside here I'm going to put this fraction, which is 10,000 or 1,000, sorry, and 35, 1030.35 over 700. Okay, and then I'm going to press this time out of the square root sign. I've got -1. Close the big bracket. Good. So that's all of this, and hopefully they'll give me the value of r, which is 2.30001, 2.3001. So 3SF is 2.30. Okay, that is the answer to question 12 part B. So that's really the first kind of slightly challenging question that we've seen on the paper so far, I guess. Most of the questions up to now have been pretty much straightforward. So yeah, this question, especially part B, you have to just know how to manipulate this. So you have to know how to deal with roots and how you can use your calculator and so on. All right, and to keep your answer as accurate as possible, I would advise you do exactly what I did. Keep these fractions exact until the end. Although, I'm not sure if that would actually give you something exact. Let's see, 1030.35 over 700. Yeah, it's something that rounds. I mean, it's not an exact value at all. So it's always better to keep things as accurate as possible. That's why I rearranged this without finding the value of this as a decimal and rounding it first. And in the end, I just put it all in my calculator and then rounded my final answer to keep accuracy. So there's the answer for question number 12, A and B, all about simple and compound interest. And other questions from this paper, which is the February-March 2022 paper 2 from from Cambridge 0580. You will have other papers from this, other questions from this paper in the playlist over here. Other questions to do with percentages and specifically interest in this playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.